Let me first introduce myself. My name is Andreas Zalonis, representing Space Hellas, who is the coordinator of MARE project. MARE is a 3-year project that started in January 2025 and ends in December of 27. And the main goal of this project is to create a security plane for 6G networks, basically a provisioning platform that can support a variety of security-related functionalities. The main objective of this project of MARE is basically to address the security-related challenges for the 6G ecosystem and the architecture as it is involved. So in that direction, the project proposes a security service platform which will host a set of security functions that can be addressed a variety of threats and attacks. So the goal is to offer this multi-domain and multi-stakeholder security and privacy environment with the ability to proactively identify the appropriate mitigation strategies to handle a variety of attack threats in the 6G networks. So, to summarize, let's say, what are the main contributions of these projects? The main contribution will be a set of security functions that can be viewed as independent blocks of software, basically offering specific security functionalities, addressing specific needs, and a smart, we call it pre-assessment environment, which includes simulation, emulation with real infrastructure, where the security-related services and functions are analyzed and tested before, let's say, the actual deployment. This is an illustration of the MARE concept. As we said, the goal is to develop a set of security functions, which, of course, will be dynamically composed to address specific attacks. The key part of this concept is the implementation of the security functions by using a set of primitive components. We call it dots in this figure. You can view these dots as independent security assets like specific tools, specific algorithms that may contribute to a specific security capability, and they can be merged together and composed into a security function. So we can view the dots as elementary building blocks that we use them to build security functions that can be reconfigured and reused across the security plane and the various needs. This is an overview of the high-level architecture. More of this will be presented in more details in the upcoming presentations, but we can say very briefly that all the functional modules that are developed in this project are mapped into this, let's say, overall architecture. The main functional modules that are working, that are responsible for the creation of the security functions, are clustered mainly in the cyber security core in the center, which is complemented by the abstraction layer, which is mostly responsible for connecting with the infrastructure, and the interface layer, which is responsible for connecting to the users, the service developers, and external stakeholders. More on those core modules will be presented in the following presentation. Just as a quick overview, the SEPE is the Security Enforcement and Policy Engine, which is basically the brain that analyzes the telemetry and plays a key role in the detection and prediction. And we have the pre-assessment and validation module, the PASTE module, which also use network digital twin to simulate attacks, to test the security functions in a safe environment, and propose the mitigation strategies and test them effectively before any live deployment. So in that way, we ensure, let's say, the continuous reliability. This approach will be tested and demonstrated and tested in in 11 proof of concepts that address specific type of attacks that are relevant to 6G ecosystems. A preliminary list of attacks. This is, let's say, an ongoing process. A preliminary list of attacks, it is listed here in this slide on the right. And these attacks and these, let's say, threats are also aligned with the different thematic areas that have been identified in the project and are listed in the left side. So for the assessment of these security functions, these POCs will be tested, analyzed in close, as much as possible, close to reality scenarios, with the use of equipment beyond 5G and 5G, equipment that forms the core network and creates the required testbeds that are going to be used in the course of this project. Of course, the expected TRL as per the work program is around 4, and this is what is the expected, let's say, results to be evaluated in those test beds and in those POCs. So, to summarize, what this project aims to do. First is, of course, to study, identify, and categorize all the threat landscape in the 6G ecosystem. The second major goal is to develop a set of security functions that can be viewed as a software that can address specific securities needs and specific securities threats, and these security functions can be dynamically composed by a set of dots of some primitive assets that can be reused in various security functions. Then we have also an environment which allows us to build these security functions, and also an environment in which we can have a smart, let's say, pre-assessment by using simulation emulation, where these security functions are analyzed and tested before their deployment. And of course, all these solutions will be aligned and be, let's say, will try to be in alignment with all the architectural concepts that have been developed in the 6G networks through the European projects and through the various international initiatives. This is a quick summary from my side. And now I will leave the floor to the next speakers to provide you a more in-depth analysis of the cybersecurity core as it has been developed in this project. Thank you.